Alright, so today we begin a relatively difficult, very hard chapter, which makes it relatively much harder on me to teach and explain. It goes by, and I'll do some writing over here, by data mining. And data mining, let's see what we have here, is focused on understanding better your data, trying to find out various patterns in the data, trying to find out different relationships. The first big thing is data exploration. You try to explore the data, just see what it is, and part of data exploration is what may be called data reduction. The second biggest part is classification. You can also say data classification. How you classify people, users, consumers, whatever. The third part is called association. How can we figure out, based on your characteristics, how we're going to form different groups? How we're going to have 3 people being friends here and 6 people being friends over there. For example, maybe those guys out there on the back, they're joined by not very interested to study, right? Or the opposite. Maybe those up front here sit together because they're eager to learn, okay? Well, maybe these 2 guys sitting out there are joined together by their passion for MacBooks, right? So they both have MacBooks, maybe they all have Lexuses, right? Of course. So somehow they are together. But is it their passion for MacBooks, or for Lexuses, or for racing bikes? Whatever joins them. Well, same thing will be in general for consumers. How consumers will choose this product or that product. In other words, in Europe, we like to say, hey, are you a BMW guy or a Mercedes guy, right? What kind of car you prefer out there? And these are the typical choices for us. Usually, we got lots of Audis, and Audis are cheap, so a lot of people buy Audis. That's a whole different story. So number 3 is association, and number 4 is cause and effect. And cause and effect is similar to association. Cause and effect will be what we discussed last time in classes. Somehow we have societies that eat tons of fat, and number 1, they're not very fat, and number 2, they don't have a lot of heart disease. And then they got major societies that don't eat a lot of animals, they don't eat a lot of fat, but the people are very fat, and they got the standard heart disease, the standard diabetes. So cause and effect. The effect will be, well, in our case, disease, sickness. And cause is the question. Is it fat causing the disease? Or is it carbohydrate causing the disease? Or is it junk food? All right. Or worse, as we had a discussion afterwards, well, maybe fats are causing or part of the cause, but now we have two types of fats known as good fats and bad fats. All right, so now you get tons and tons of statistical data, which is very easy to get. And the question now becomes, well, which are good fats and which are bad fats? So you're trying to get the cause between bad fats and disease, good fats and health, but at the same time, you try to classify what would be a good fat and what would be a bad fat. Of course, that's using statistics. You could approach the problem very simply and easily with common sense. And with common sense, it's a lot easier. Hey, how long we've had humans living? Well, maybe 3, maybe 4 million people. What kind of fat human ate for 3 million people? The answer is saturated fats and animal fats. There weren't any other fats. All right? Cooking oils were non-existent, at least, they were existent maybe for 100 years. So for 3 million people, 3 million years, we've adapted to saturated fat, okay? And we have not been adapted to corn oil and canola oil and all of those other vegetable oils. But again, this is a statistical hypothesis using common sense as a statistical hypothesis. Hypothesis that animal fats and saturated fats are healthy because we've been adapted for 3 million years, and that vegetable oils, being a result of chemical, factory, industrial products, for barely 60 or 80 years, we have not been able to adjust and adapt. And therefore, they are probably unhealthy. Again, that's a statistical hypothesis. So one way to run the hypothesis is to classify now fats into saturated and non-saturated, or animal fats and vegetable fats, and then try to determine cause and effect. So you can run classification, you can run cause and effect. All right, that's good enough. Let's see what we have. Well, they've given you the same things on this slide. Data, exploration, and reduction, number 1. Classification is number 2. Remember, classification may be sometimes common sense. You may use common sense for classification. You may use science, okay? But classification sometimes cannot use common sense. Like, which students are likely to graduate from the university and which students are not likely to graduate. Of course, we may have 95% of the students are likely to graduate and only 5% will not graduate. Well, how do we identify the 5%? Do we look into their attendance, and based on attendance? Do we look into their GPA? Or do we look into where they sit on the back, being busy with their phones, both of them, yeah. Sitting on the back, yeah. All right, so come over up front so I can see you there. The one on the back. Yeah, yeah, just come up front here. You too. The other guy in the back, just come up front. All right, so how do we determine? Do we determine them by where they sit, or their attendance, or in classification, we'll find out that there's a major correlation between where they sit and their attendance. Those people that usually don't attend a lot, they usually sit on the back. All right, and there's a correlation with a low GPA. So it turns out that they can find various characteristics and they would be similar. Okay, that's the classification. And similar with association, what determines and analyze natural association. All right, let's try and move on. So, you can do basic data exploration. That's number one. SPP is not very good for data exploration. But SPSS, if you have the commercial version, is very good. It's got tons of graphics and versions and forms of graphics. And Excel actually has some good graphics. So when it comes to graphical analysis, data exploration, it may be that Excel is a little better than PSPP, but not better than SPSS. SPSS is the commercial version. It's 10 times bigger. It's also expensive. To have an SPSS legally costs about $1,000 per copy. Oh, it's an expensive software, but it still works very well. So you can use what they have as XLMiner. And they give you, well, here's a worksheet, this is what you do. Again, if you decide one day that you need some of these techniques, and you need these techniques, you can probably also use them in Excel by simply following the screenshots. Again, the PowerPoint slides are freely available. So you look, still a sample worksheet and whatnot and different things and stuff. And it gives you some results and it tells you what it is. Again, for data visualization, you can use it different charts, different types of charts, with these little bars and what's the ranges of months of whatever being employed and being employed and being employed, and you see single guys have usually more months of being employed. So we basically use different visualization types. So this is one of the many dozens of different types of charts. You could use a parallel coordinates charts. Again, that's not what I'm trying to teach today. What I'm trying to teach today, I'll get on slide 15. For example, you got all of these different visualizations, what it looks like. You can also use scatter plot matrices. So you got some variables over here, you got some variables over here, and you can look at the data. What do they look like? Okay, this is what they look like here. This is what the scatter plots look like. So you can visualize your data in hundreds of different ways. Hundreds of different ways. And you can use one and the same type of chart in many different ways. Again, so slice, dice, and visualize the data. Just visualizing the data is, again, an art in itself. And then, of course, when you have certain outliers against the same old story, what do we do with those? Again, variable plot, and these are some variable plots. Again, a lot of different things, and the bar charts and all the other things of how you slice and dice the different data by different things. And again, you can look by months of customer, you can look by age, you can look by credit risk high and low, you can look by whatever the job is, unemployed, single, whatever. So you can look at your data and guess what is the relationship that you may actually need. Well, that's the one thing. If you live in the real world, one of the more important things is dirty data, especially when you do marketing data, sales data, survey data, even financial market data. Sometimes the data is missing. That's very, very, very common. And if data is missing, you need to figure out what you have to do. Do you delete the data? Maybe just delete the whole row. Maybe just delete the whole observation. Okay? You just ignore it again. Maybe you will plug in some mean value. Maybe you'll plug in the median value. Again, you may have different approaches, But one thing is sure. If you have dirty data, you gotta clean it up. So, the two approaches to cleaning up is, number one, delete the data, but deleting the data can introduce bias. Okay, for example, you asked a lot of people certain question, and let's say out of 50 people, 10 people did not answer. But it may be that they had a reason not to answer, an economic reason or a personal reason. So the data was empty or blank, the value was missing because there was a true, genuine economic or personal reason. For example, ask people about divorces and what was the cause of your divorce? Answer A, it was my fault. Answer B, it was her fault. And the guy didn't answer, right? Maybe he didn't answer because it was his fault, right? So there may be circumstances where when you ask people, they don't want to answer because the answer is inconvenient or they don't like the answer, okay? So that's the case for missing that. Well, you may have missing values, let's say trading. You got markets we discussed in the East and in the West, and you want to make a correlation between trading in American markets and trading in Asian markets, and you want to get a correlation for diversification. Well, today, whatever may mind, the Chinese market is closed. You will not have data just because it's a holiday, okay? Well, that's a case of missing data. So you need to decide what to do. Are you going to delete the whole day or going to put yesterday's close? Okay. Now I got even weirder stuff. I don't know, maybe you've heard, maybe you haven't heard. Holiday or the weekend in Saudi Arabia is Thursday and Friday. On Thursday they don't work, and on Friday they don't work, and they work on Saturday and Sunday. Now when I worked in Bahrain, they kind of like halfway. They work the holidays Friday and Saturday, but Sunday is a regular work day. So now you try to correlate the Arab markets, and they're open on Sundays, but Western markets are closed on Sundays. And then on, let's say, Friday, the Western market is open, but let's say the Middle Eastern market is closed. Well, what do? You're going to get some sort of dirty data, all right? So somehow you need to use common sense or technique. Some way you need to clean up the data. You need to figure out how to approach it. And again, it's important to understand that there is no one single perfect way to do it. It will depend on why the data is dirty. What's the cause? What's driving the dirty data? Maybe it was not recorded. Maybe someone mistyped, okay, and gave it, oh, the respondent's age is 111 years old. Well, maybe not, right? Maybe they just mistyped in the data, okay? All right, so now that I spent 25 minutes on all these introductions, I got two specific topics to cover. Topic number one is cluster analysis, which is also data segmentation. Is a collection of different techniques, a number of different ways, which we use to group or segment the people. So how are we going to divide this class into groups, or in 3 groups, or in 5 groups? If we need to make different groups, how are we going to do it? Again, we're going to have different criteria. It may be male, female, the city, the province, nationals, foreigners, GPA above 3, GPA below 3, sitting up front, sitting on the back, okay? So, driving old Lexus, right? Well, maybe the characterization could be simply running an Android, like Samsung Galaxy versus iPhone. Having a Windows laptop versus, again, MacBook, right? So somehow we need to group the people. If we need to separate them in 3 groups, how are we going to do that? So that's cluster analysis. We try to get them into subsets, say 3 groups or 3, call them clusters. So those within each cluster are sampled how more closely related to all others, somehow. So, cluster in hierarchical clustering, you can use agglomerative, and the other one is divisive. The picture looks like this. In agglomerative methods, you take the whole thing, actually, sorry, in agglomerative, you take at the bottom, okay, and then you say, oh, A and B are closer. And then A and D are not closer, D and E is closer, okay? And then you say, oh, A and B and C is closer. So if you need to divide them into 2 clusters, A and B will get together, A, B, and C will get, that's the one cluster, and D and E is going to be the second cluster. In the divisive method, it's the opposite. You take A, B, C, and D, and if you spread them into 2 clusters, you're going to get A, B, C, and then D, E. If you need 3 clusters, it may be AB is the one cluster, DE is the second cluster, and C is the third cluster. All right. So everyone is only in one cluster. If you need 4, maybe you can do A, B, C, D, E. Okay. Or maybe you do A, B, C, D, E. If you need to separate them out into 4 clusters. So the approach may be up-down or down-up approach. Well, if you're having a cluster, you need to have a definition of similar. What does it mean, similar? Similar is usually defined by some sort of a distance. The distance between sitting each other. So you may be very similar just because you sit next to each other. Or you may be similar because you have long, equally long hair. Or it may be similar because you both have 4.0 GPA, right? That will be similar, right? That's a similarity. Or maybe because you drink the same kind of drink. Again, depending on how we define similarity. Similarity is defined by the characteristics. Differences is in distance. So we usually use in mathematics and statistics a standard distance. So we use the distance between 2 points is called Euclidian distance, is defined in a very simple way, just like you study in your geography. Just take 2 points and you measure by the coordinates. Okay? So that's a basic way to measure distance. Now, things get fairly complicated. If you have distance between 2 points, it's relatively easy to determine what it is. Now, things get a lot more complicated when you have distance between groups. Camera. Here is group A, okay, and now here is group B. How we measure distance between groups is not clear. It's very clear how we measure between 2 points, A and B. Distance is usually defined by the shortest distance, usually being a straight line. Well, here we can use distance, but which one? So, one way to define distance is say, well, we take the closest points and that defines distance between A and B. So distance between A and B, this is going to be A3 and B7. So this could be the distance between two sets. But distance could be defined by the two farthest points. You may define distance between this one here and this one here will give you the largest distance. Those right, yeah. Yeah, the one that you're having fun, come over here. Or here. Yeah, too much fun. All right, next. While we're all waiting on her to move, distance could be defined. You take for these the center. You take this is going to be the center. So of all the points here, you get the middle point. Okay. And then of all the points here, you get the middle point. And then you take the distance between the middle points. And then you may use some sort of a weighting scheme. So that's what these guys are basically. Single-linkage, you know, nearest neighbor. The distance between two groups is defined as the distance between the closest pair of objects. So this first one will be these, A3 and B7. Complete, the distance between groups is the distance between the most distant pair of objects. So it's going to be this further out here and this further out here. Or you know, you could use the mean values for each variable to compute. So there are different ways, and the problem is basic, that you may define distance between two sets in different ways. You have to make a basic choice. Of course, if you define distance differently, you will get different results in different clusters, okay? But you use one of them, and please try to see what happens. Using one of them is better than doing nothing. And they got a clustering for colleges and universities. You ask, well, what do we want to classify? We want to classify by school type. And then we use the median SAT, the acceptance, whatnot, and we try to see the different schools by some kind of a, and they give you here, well, this is what it is and this is what it does. Continued cluster, whatnot. And let's see, select the number of clusters. Sometimes you ask the data, well, give me what happens with 2 clusters, 3 clusters, 4 clusters, 5 clusters. Sometimes we usually determine upfront how many clusters we want or how many clusters we need. Maybe we just need 2 clusters. Maybe we need 5 clusters upfront. Maybe we need 10. Again, sometimes we'll know upfront how many clusters we need. Sometimes what we may have to do is let's pick 3 clusters and see what happens. Then let's pick 5 clusters and see what happens. Maybe pick 10 clusters and see what happens. But we usually use a number of clusters and we give it up front for the calculation. And when you do the calculations, it gives you some data, whatever the variables are. You do some stuff, and you can get a simple chart. If you got to divide in 2 groups here, you use, hey, this is the one group on this end, and this is the other group on this end. Okay. If you need, let's say, more groups, here's one group here, here's a second group here, here's one group over here. Again, somehow the software will divide for you and give you the different groups. And eventually, when you get the data, the key, the final result will be something like this. For all of these data, the first one is cluster ID number 1. Second one is cluster ID 2, cluster ID 2, cluster ID 3, 1, 1, 2, 4, 1, 2, 2, 2, 2, 1, 1, 1, 2, 2. So basically, the software gives you which observation belongs to which cluster. If it's students, which student belongs to which group. Again, we don't know what the group is. We still have to look into what unifies the group. Is it the way they sit? Is it the GPA? Is it the kind of car? Again, we don't know. We'll have to look into the data to find what determines the cluster. What is that thing that makes people similar to each other? So that's on clustering. We have, and I'm trying to remember, a simple command, which is, I think it's called simple cluster. There is a command called cluster in our regression. Maybe I can try. I don't know if I can do this thing now over here. Oh, I need to minimize software. I need to open the PSPP manual, okay. And in the PSPP manual, remember, we gotta open here the statistics. Oh, okay, there it is. Oh, it's not coming up. Okay, let's see how I do this thing here. Anyway, I got it. It's called, let me write it for you, quick cluster. Quick cluster is the command that you will use. You will see the syntax. It just says, give me the variables, you give me the criteria in terms of number of clusters, maximum iterations, what you do with the missing values, and then print them, okay? It's very simple, very easy, very straightforward. It will take between 1 and 2 minutes to learn how to do it, okay? So we just gotta say, I need 3 clusters, I need 7 clusters, and answer. Print the data. Again, you have to be careful. You have huge data with thousands of observations that you can't just print. All right, so that's number 1. Let's see what else I got in here. Back to the slides. Next will be classification methods. Classifications, we try to classify categorical outcomes into 1 or 2 more categories. So, in classification, the key is categories. The category may be win or lose. It could be in the stock market, make money, lose money. The classification, the category may be graduate from school, not graduated from school. The category may be married or single, okay? Well, we can use a completely different categories. That's very common, unfortunately, in the West. For married women, have child, doesn't have a child. Maybe it's the career. If she's got a good high-paying job in a career, she doesn't have a child because she don't want to have a child. Okay, that's one case. Now, the more common case is maybe she wants a child but can't have it because it's too fat. And sometimes not being able to conceive. Okay, these things do happen in the real world. Okay. So, the category could be any kind. Well, it's possible to have 3 categories, okay? Like single, married, divorced. It's possible to have 3. Well, it's normal to have 3 categories. Okay, well, the 3 categories for those guys back there, the 2 of you. 3 categories will be, yeah, the 2 of you guys know. MacBook Pro, MacBook Air or just the brand new 12-inch MacBook, which is not Pro and which is not Air. Now I got 3 MacBooks. Pro, Air, and just MacBook, 12-inch, right? So, these are the 3 categories. The question is, if you're a MacBook guy, which one do you choose? Do you choose the Pro, the Air, or the skinny one, right? The 12-inch super skinny ultra light. Okay. So, how do you determine the categories? Okay. Well, the categories could be, well, in this particular case, they're categorical. Instead of Win, it could be Android and iPhone. Okay, that's a simple category. Well, of course, the category could be car versus motorcycle. Again, tons and tons of categories. Let's move on and see what we got in here. So, decision, maybe for credits. Borrow or doesn't borrow. Or have a house, doesn't have a house. Or decision, approve credit, reject credit. Again, you can have lots of different variables, so you try to figure out what the relationship is. And you try to classify in different ways. Let's see what's going on. Classification matrix. Okay, use training data sets. I need to go quickly to what is coming up next. Classifying data. All right. Here in classification. Okay, camera, I'll have to rewrite again. We have K nearest neighbors. So by nearest neighbors, you can classify. Use find records and that have similar numerical values. Okay, this is similar to the clusters, quite the same. You can also use discriminant analysis. And finally, you could use logistic regression. And logistic regression estimates the probability of belonging to a category using the regression of the predictor variable. Now, some softwares have discriminant analysis, some softwares have K nearest neighbors, but for you the good news is that we don't have the first two, we got only logistic regression, which means that I'll jump through these first and I'll go straight to logistic regression. I gotta see where's my little note over here. We just go through, I think of so K nearest neighbors, they give you examples. Then discriminant analysis, this is what it is. I'll skip again. Discriminant classifying using discriminant analysis. How to classify the discriminant they give you. And finally, we got about 6 or 7 slides and maybe 5 or 6 minutes for logistic regression. Logistic regression is a variation of linear regression. So it's a type of linear regression. The dependent variable is categorical. So in a linear regression, you can have a standard variable like what's your GPA, 3.8, 3.9, or 2.2. So it could be, or what's your weight? 60 kilograms, 42, 47, 58. So you can have a continuous variable, or the categorical variable will pass the course, will fail the course, okay? So that's a categorical variable. And in our case, the categorical variable with logistic analysis is binary, means only 2 values, only 2 values. So logistic analysis doesn't work with colors. It's not going to work with the MacBook Pro Air. If you have 3 values, it won't work, okay? It may work with married, not married, but it won't work with 3 values. So logistical analysis can be applied only if the variable in interest has 2 values. That's important to understand. It is a statistical transformation where it has yes and no. You will calculate a probability for yes, and you'll calculate the probability for no. And you got 1 probability for yes, one probability for no. The probability for yes we call P, well it becomes P. And the probability for no is 1 minus P. And in order to make the statistics works nice, you will take the log of P, and there is some property in this P over 1 over P. Well, you just run a standard linear regression of the log of probability ratios. The probability ratio P divided by 1 over P is called the odds ratio. I can maybe explain it like this. Let's say the chance is for 1 is 80% and 1 minus P is 20%. The ratio is 4 to 1. Okay, that's a simple ratio. Well, if P is 50% and 1 minus P is 50%, the ratio is 1 to 1. Okay. Well, the ratio could be 1 to 100. It could be 100 to 1. It could be 1,000 to 1. So the ratio could be pretty much any positive number. Okay. And when you take the log, this is called the odds ratio. When you take the log of any positive number will be converted between 0 and 1. And that's how logistic regression. It is still a linear regression of the odds. Okay, and then you solve, well, the software does the solution for you. The software does the solution. You see what it is. And then you look at basically what the results are. It tells you what is the coefficient for each variable. And based on these coefficients, you can calculate later on the probability. The probability of having a MacBook versus Air, of being single versus married, of being a graduating student versus a failing student. And you can use that data when you have a new student or when you have somebody else to determine, is this person likely to buy an Android phone or likely to buy an iPhone? Okay. So, or is this new student likely to pass or likely to fail? Okay. Example. Well, let me just give you 1 minute. 20 years ago, 22 years ago, 93, 94, the University of Delaware was making a research. They are running a master's program in economics. And when they run the master's program in economics, they are admitting, they come to Bulgaria and they hire a whole bunch of Bulgarians trying to see, to give us a master's degree. So they admit maybe 100 people. And out of these 100 people, 80 people will fail very quickly. And eventually, 15 people will graduate. When you graduate, you rank the students by performance, and you check the indicators which will indicate the success of the student. The indicator could be their GPA from undergraduate. This is a master's in economics. It could be their English language skills. It could be the preliminary entrance test. Okay. So when they ran the statistics to figure out what was the determinant to success, meaning the best determinant of success, they discovered that the best determinant of success was a 20-minute interview where Professor Jeff Miller from the University of Delaware ranked and gave a score on each student, and his score was the best correlation with the performance of that student a year and a half later. So you can run the most sophisticated test, can't compare to the judgment of Jeff Miller. You can take the GPA of undergraduate degree for 4 years, and it can't compare to the 15 minutes judgment of, again, 15-minute conversation with Jenny Taylor. So this is an example of trying to get an association. The cause and effect is maybe another time. Here, the regression was called just one last minute. If you remember, let me try and see. The regression was called logistic. Let me take the user manual. Was it here it's called logistic regression. So basically, for the current chapter, you need to learn how to use these two commands. Of course, there is a cluster window, and of course, there is a logistic regression window. You can use the window straight, or you can just write the code itself. Either way, you should learn how to use it, what it means, and how to interpret. So for this chapter, we'll be doing the problems mostly with clustering and logistic regression. All right.